Today we are going to take a look at some more transformations of y equals sine x. So we're going to look at horizontal and vertical stretches. So when we are looking at y equals sine x or y equals sine theta, when we put a number out front, remember this changes our functions the same way it did our quadratic functions in the same method. So that a value out front changes or stretches vertically our base function, which means that our amplitude is going to change because our graph is going to be taller. And because we have a max and min in sine functions, that means that both are going to change. So both are going to be multiplied by that 4 out front. And what's going to happen to our key points here is that our y values are going to be multiplied by 4. Okay, so our period is not affected. Our period is still going to be 360 degrees. On our y-axis, we're going to have to go from a max now of 4, and we're going to have a minimum of -4. Notice those have both been multiplied by 4. Our amplitude now, where it was 1, our amplitude now becomes max minus min divided by 2, which gives us 4. And that makes sense because our graph is 4 times taller, and we talked about regular amplitude being 1, makes sense that it should be 4 now. Now our domain of our function y equals sine x is x can be any real number. We can sub any value for our angles in there and find our sine. Now if we were talking about one cycle, then we would have a minimum and a maximum for that cycle. But in general, the function itself, x can be any real number. Now, our range though, y in this case, y in between, y is greater than or equal to -4, our minimum, but smaller than or equal to +4, our maximum. And as long as it is, it can be anything in between there. So, all we've changed is our altitude. Period is still the same. So now we want to make sure that we have at least 4 and -4 on our grid. So we're going to make every other block 1. So each of our blocks has a value of 0.5. We're going to make sure that our key points are very easy to graph. Our period hasn't changed. So we're going to make every 390. Same into our negatives. And again, making it easy to graph our key points. So our base function, 0 up to 1, back to 0, down to -1, back to 0. Same thing in our negatives. And again, I'm going to use a dotted line to represent this because it's not our final graph. And again, this is our base graph of sine y equals sine x. Now, all of our points are stretched. The y values are multiplied by 4. So 0 times 4 is still 0. So we still have a base or a starting point of 0, 0. But now becomes 90 and 4. Back to 0, down to -4, back to 0. On the opposite side, to -4, to 0, to +4, back to 0. And again, we make sure that we're graphing a nice, smooth curve. I'm sorry, mine isn't great because of writing on the tablet. But we still have the same period, 1 cycle in 360, but now we have 4 times taller, and we have our graph of y equals 4 sine x. Now we're going to graph y equals half sine x. So again, this is a vertical compression because we have an a value out front of less than 1. So x doesn't change, but we're going to have 1/2 times what our y values are. When we graph this, it's going to change our scale on the y-axis. Our period is still 360. We're going to have a maximum now of 1/2 and a minimum of -1/2. Our amplitude is going to be 1/2. Remember, amplitude is kind of a measure of height, so it's got to be a positive value, and again is half the distance or the height of the entire graph, or the distance from the top to the bottom from the middle, top or the bottom to the middle. So we could also think about it as 1/2 minus 1/2 divided by 2, which also gives us 1/2. Again, our domain of the entire function, x can be anything, but now, again, our minimum value is -1/2, maximum value is +1/2, so y is greater than or equal to -1/2, smaller than or equal to 1/2. So we're going to think about that when we're scaling our grid. We need to go up to 1/2 and down to -1/2. So we're going to stretch this out a little bit. And we know that we can use whatever scaling we want as long as this is all going to fit in there. And that's another reason when you see graphs, you really want to pay attention to the scaling because they're not necessarily scaled all the same. We're still going to use the same scale for our x-axis that we did in our previous question because our period is still 360. So now creating our base graph, we don't really have to put our base graph in here. We know that we're going to start at 0, 0. Our pattern is going to stay the same. Our key points still happen every 90. We just don't go up to 1. We only go up to +1 down to -1 for our graph. Okay, so the only thing that has changed here is our amplitude, and we adjust that accordingly. And we now have our graph of y equals 1/2 sine x. Now, we can also have a value in front of x here. So, our properties that are affected, now we have a horizontal stretch or compression. So, this is going to affect our period now, which in turn is going to affect how often our key points are going to happen. So if we have x and y, our regular points, what's going to change is that we're going to multiply our x values. Now we talked about adding or subtracting inside the brackets with x does the opposite. Well, k value also does the opposite, that we are going to be looking at 1 over k. So we're going to multiply our x values by 1 over k. So the 3 out front here is actually going to compress our graph. Opposite of what it does with the number for y out front, it is going to affect our x values. So our period is now going to be multiplied by 1 over k, which in this case is 360 times 1/3, which is the same thing as dividing by 3. So our period is only 120 degrees here. Okay, it's 1/3 as big. A third of 360 is 120, does the opposite. So compressed by a factor of 3. Our x-axis, we still have a maximum of 1, a minimum of -1. Our amplitude doesn't change. Our domain, again, for the entire function, doesn't change. It's still x can be any real number. But if we're talking about one cycle of that, that would be altered. Our range, because our amplitude hasn't changed, we are still talking about -1 to +1 for our y values. And for that reason, when we graph it, we're going to keep that in mind, that we don't have to go any further than -1 or 1. So we're going to stretch it out a little bit. Now, we can still graph our cycle starting at 0, 0, and we can still use 3 blocks as our key points, but the value of those blocks is different. So if we want to use our key points, we're going to go through a cycle in 120 degrees. So that means that if we look at splitting that into basically 4 equal sections, like we do 90, 180, 270, 360, we're now going to be talking about 30 degrees, 60 degrees, and 90 degrees. So -30, -60. So we can see how we can alter our scaling of our grid as well. So our graph might look exactly the same as it did originally, but the scale is different. And again, I apologize, mine isn't the greatest smooth curve. Doing it here on the tablet. Okay, so notice now, this does look like our regular sine graph, but we notice that the scaling is different. For y equals 2 sine 1/4 x, okay, we have to focus on how we're going to change our scaling. Key points still going to happen 4 in a cycle basically, or sorry, 5 in a cycle, 0, 90, 180, 270, 360. That those numbers may change though accordingly. So taking a look at this, we know that our graph, 1/4 in here means it's going to be a stretch of 4, opposite as to what this number here does. So we're going to be multiplying our values by 4, stretch of 4, and we're going to be also multiplying our y values by 2. So multiplying our x values means that our period is going to change as well. So our period of 360 gets multiplied by the reciprocal of 1/4, which is multiplying by 4. So our period is now going to be 1440. Okay, so one cycle is going to happen in 1440 degrees. Our x-axis, our max, is going to be 1 times 2, so 2. Our min is going to be -1 times 2, which gives us -2, stretched by 2. Our amplitude then has to be 2, 1 times 2. Our domain, again, x can be any real number. range y has to be greater than or equal to -2, but smaller than or equal to +2. And we're going to keep that in mind when we're labeling our graph. So we're going to have y, x. We know we need to go up to 2 and down to -2. We know that we're going to go, since we're going 1440, we're still going to have key points, regular intervals, 0. And we can still think about making those key points every 3 places or blocks on our grid. We're just going to, again, scale it a little differently. That if this is 1440, this is going to be 720. And again, thinking about our key points, we can think about how those change as well. They normally happen every 90. Well, now they're going to happen multiplied by 4, so they're going to happen every 360 degrees. So we know we're going to have 360, 720, and 1080. And that's going to be the same into the negatives. And we could spread those out a little bit more as well. So, key points. Again, you could graph. What I would probably suggest is, and we'll talk about this more when we have more combinations of things, but I would graph my stretches and compressions first and then look at my translations. So starting at 0, 0, first key point is at 360, max of 2, 720 and 0, 1080 and -2, and so on. And again, thinking about our key points as we go to plot these fairly quickly. Okay, so we have our graph of y equals 2 sine 1/4 x. So, in general, our a value out front of sine x means a vertical stretch or compression. It is a vertical stretch when a is greater than 1. We have a vertical compression when our a value is less than 1. And we're going to talk about our absolute values here. So the absolute value of a can be a negative, which would be a reflection. We've talked about reflections of quadratics, turning it the other way or flipping it around the x-axis. We can still have an a value here for these that way as well, and we'll look at that as well. But we're going to talk about the absolute value of a aside from the negative, and that's where your absolute value comes into with the lines on either side. Just means solely thinking about the positive value of that a to take a look at whether it's a stretch or a compression. And b in here is a horizontal transformation. And we have a horizontal stretch if b is less than 1. Okay, so opposite, and again, absolute value. We can have a negative in there, but we're going to talk about solely focusing on the positive value. And if our absolute value of b is greater than 1, then it does the opposite and is compressed. So if we have 3, it's compressed by 3. It's 1/3 as wide. If b is 1/2, it's twice as wide. We look at the reciprocal of the b value to see what's happening to our x or theta values. Okay, so you have some questions to practice. Keep all of those in mind, and as always, if you have any questions, let me know. Take care.